All right, so some examples with strings. Let's create a new package for this. All right, let's just, first I want to test some of the basics of using strings. Okay, so that's going to be my test string. Goog. Okay, so now what are some of the things that we can do with that? Well, one of the things is this length. So how many characters are there? And we see there are 71 characters there. Let's look for the first index of, let's look for, okay, now notice that I can either use, if I'm just looking for one character, then I use single quotes. If I'm looking for a string, I need to use double quotes. Some languages like Python are kind of agnostic about that. Java is not. Java is very picky. So I can't just use single or double quotes as I see fit. A single quote has to be a single character, and a double quote can be an arbitrary string. So the index of t would be, okay, the first t I would expect 0, 1, 2, 3, 4, 5, 6, 7. I'm looking for 7. Okay, so I did well on that. Here's, well, okay, here's something that occasionally that you want to do, where your string is a file name. This is a very useful use case, and I just want to get the name of the file, but without the extension. Or maybe I want to get the extension to figure out what kind of file it is. So. Okay, so the file name, I want to look for the last index of a dot. And again, I can give it a character if I want that. So that will give me index of dot. Okay, so that should be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that tells me that the index of that is 9. And so what I can do is get the name without extension as the substring and what I'm looking for is the substring of, in this case, it would be 0 through the index of dot. And I need to, what I don't remember is begins and then extends to the character at the index, at the end index. minus 1. So that will give me the name without extension. So let's see if that. So I'm looking for just a file name without the txt. So what I've been able to do is strip out the file name, if that's what I'm looking for. Or I may be after the extension. And so for that, again, I can look at the substring, returns a string that is a substring of this string, begins with the character at the specified index and extends to the end of the string. And so what I want is actually the index of dot plus 1. Okay, so the main use that I found of this is that if I'm reading in a file and I want to know what kind of file it is, because if it's a text file, I want to do one thing. If it's a CSV file, I may want to do something else entirely. Or, maybe it's there are now I may need third libraries for this. It might be a spreadsheet. I might want to do something with that. There are ways of dealing with that. It could be a database. It could be what is the other? It could be like a PDF file. Again, those are binary files. There are third-party libraries that I can use to read those in. So this is a useful way, and this is one of the reasons why I feel that kind of knowing things like this is kind of important, because I've found them to be useful myself. So here I've taken a file and I've extracted both its name and its extension. Now it's not, to be clear, basing the type of file on the extension is actually kind of a fragile thing, because files can be named with any extension, but that's still a common way of dealing with it. The alternatives are, you can kind of peek at many times the first few bytes of the file will kind of be more informative as far as what it is, but that's not what we're dealing with here. Okay, so let's look at some of the replace stuff. So supposing I want to replace my O's to zeros. Oops, not repeat, replace. See, they're actually a bazillion. Okay, so replace, I want to replace my O's with zeros. Why? So, because. Oops. Okay, so here I've replaced all the O's with zeros. What if I, another, okay, so that should be, let's say I just want to replace the first. I say replace first. Now notice that it says it's a regular expression. Why aren't you? But nevertheless, I can give it, okay, now just to understand syntactically, any string is a regular expression. So the regular expression O in this case, will match O and replace first will just replace the first one, as we will see. Oops. Where to go?
System.
So, syst. Fat fingers this morning. Okay, so here it only replaced the first one and left the rest of them there. Okay, now here's something that is quite useful, and that's the split. Yesterday I talked about the split. And what split does is split. You notice that there are, it says splits a string, it matches the given regular expression. Again, we haven't delved deeply into regular expressions yet, so we can still use a a space. Again, a space is a single character. It's not nothing. And so this says, what this will do is it will use the space as a delimiter, meaning that will not appear, and then it'll split my string here and just give me everything that's separated by a space. Okay? So let's since it's an array, just to be lazy, I'll just print them out that way. And as you can see, that it's taken all of my stuff and it's turned it into an array. And now I can deal with that. All right. So now, why regular expressions, you ask? Well, supposing I have a bunch of these, supposing I have more than one will actually kind of work, but supposing I have a bunch of tabs in there. Now what's that going to do? Well, a space is not going to match a tab. A space and a tab are two different things. So when I split according to a space, it will treat the tab as part of the word itself. So when I run it, actually, notice that here, when I was processing it, now all these tabs are there, and now when I'm printing it out here, all of a sudden these tabs start appearing. Okay, so now I want to say, I want to match a tab or a space. How can I do that? Well,
why is the tab so small between the all and good when it prints out? Because it created the tab as its own space, but then why doesn't it print out at the full tab length?
I'm not quite following you, because see here all, so it split space, and then gave a tab. And you say, why isn't it bigger?
Because if you look at the two, it has, or before the two, it has the same spacing.
Yeah. I think it just has to do with the way that it prints things out, that if it just has a single tab, it gives you, like this thing here, see it right there? I mean, that's the tab.
Yeah.
And then, but then if it's part of a string, then it kind of turns it into spaces. That actually may be a NetBeans thing. I'm not entirely sure. But yeah, those are tabs there. And they're there because space doesn't match a tab. All right. So, and is it possible to get a string that has tabs and stuff in here? Absolutely. In fact, this is one of the reasons why Python can be really problematic, because if a tab gets into your stuff, you can't see it, and it looks okay, but it won't compile because Python is very picky that way. but that's another language. All right, so how can we match? I want to match either a space or a tab. Well, what I can do with regular expressions is put things in brackets. Okay, so this wasn't on the slide, but okay, what this bracket says is match anything that is a tab or a space. Okay, so now, all right, now and that's not going to be absolutely perfect. And as you can see here, I'm getting a bunch of actually kind of empty stuff, and then here's something that kind of snuck in as well. Okay, what went wrong? Well, here I had a space, tab, etc. So I matched, what it did was it split stuff up based on a single space or a single tab. And what if I want to have more than one? Well, again, this wasn't on the slides, but there's another magic incantation, which is a plus. And so a plus is when you add stuff. And in regular expressions, when I say plus, it means one or more. So this will match one or more space or tab. And so what that will do is in situations here where I got a space and a couple of tabs, or here space, tab, space, it will now treat all that as just one thing, because space or tab plus says any sequence of tabs and spaces is going to be treated as one thing to split on. All right, what if but wait, there's more. What if I throw in something like this? Okay, I just threw in a new line. Right now, okay, it's messing up all these things, but now look at this. Now all of a sudden that new line is in there. Why? Because it wasn't matched. So what can I do? I can add the new line in here. And now we're back to where we were. And it turns out that there are some other character sequences that kind of match this. So therefore, what they've come up with, let me just save this for, okay, I'm gonna comment that. So what they've come up with is another magic sequence called, I don't need to bracket it, S. \S is white space, any white space. And a white space is a space, tab, new line, or there are some other UTF characters that are non-printing. And so this will have the same effect as what we had before, so regardless of what that is. So I hope you're getting a little bit of a sense of why these regular expressions can be useful. So I mean, again, we had a task and we wanted to take what we had here and we wanted to take this sentence, as it were, that had a bunch of stuff in it. And it is very common to have stuff you can't see in these strings, but we wanted to kind of ignore all the white space and just identify what the words were. So we could either, and as we saw, okay, if we just did spaces and there happened to be tabs in there, then it produced some problems. So then when we were able to kind of nail that down. If we didn't have regular expressions, what would you do? I mean, you'd have to kind of write some maybe very special code that would possibly break this down into characters and try to figure out where the spaces were and what everything else was. I mean, again, think about how you would do this task of taking a string like this and turning it into individual words by ignoring the spaces and the tabs and the new lines. I mean, how would you do that? Here we can do it basically with this one call. Okay, so that's